In this issue of Spacecraft Guide, I am continue to show you how to fly the space shuttle and how it flies in outer space, and give you a chance to win a book whose text has been in outer space. But before we do that, we're going to continue our work on the reaction control system, and from that we're going to work on switches that give the fuel directly to the jets, and those are going to be the forward reaction control system main isolation switches. And when you click on them, it takes you to the reaction control manifold isolation switch. And if you look at the switches, we're talking about the ones at the bottom here. And what these switches do is that they control a pair of valves, one fuel and one oxidizer. That's going to be very important, which allow propellant to flow to the jets on the corresponding manifold. So that's the fuel manifold and the oxidizer manifold. When the valves are between the tank isolation valves and the forward RCS, or reaction control system jets. So here are the switches, and you see this has one line coming down, but this is kind of deceptive because that one line, it has a fuel line and an oxidizer line, a pressured line. They have not been continued. What happens is you open this switch, and then from the manifold that it gets it from, it's going to control or put fuel to these jets here, the F1 left, F1 up, F1 down, and F1 forward. So those are all ones in the forward, and your left, up, down, or down and forward. So that's all in this one switch. And you can see here they have this one switch does forward to right, forward to up, forward to down, and forward to forward. So this is the panel that it's going to be on, which is the forward nose of the shuttle. This is the jet, and this is the jet number, which is number 2, and this is the direction, all with this one switch. And you can see it's also here on for forward 3, forward 4, and forward 5. So that's all the jets here. And what they're doing is there is a manifold up here. And this manifold on top, as we look through the switches, before, if you've done the other, if you watch the other episodes, there are 2 lines with this one. So there is, think of it as fuel 1 and oxidizer 1. That's what this switch controls. So that is what this switch here does for the space shuttle. It actually moves the fuel and oxidizer to the jet. Now, that is all for our YouTube people. For our Patreon subscribers, we're going to go a little bit deeper into schematics, and also for our paying Patreon subscribers, we're going to go deeper into these jets. And then finally, if you stay till the end, you'll see how you can find a book that has been put, whose text has been put into outer space and now is on sale on Amazon. I'm going to show you about that right after I get done with this portion of the video. So if you are a paying or free subscriber, doesn't cost you anything, and you click on schematics, it takes you to the reaction control system schematics, and where we are is right here. And you see you have isolation manifold in with the manifold coming down here. You have 1, 2, 3, 4, 5. This is what we're talking about with the switch, which does the manifold pressure 1, manifold pressure 2, and that, again, this is the oxidizer, and then there's going to be another one that's going to say fuel, and those both are going to come down and go to the jet. So if we look let's see, this is the aft, and here is the forward. So what's happening is we've got the nitrogen right here, or I'm sorry, nitrogen, the helium right here, and it's got the pressure for the oxidizer and the helium, and this is the valve. It's coming down to the switch, and this valve is going to be open or closed according to this switch, and that helium for the oxidizer is going to go to the helium tank, as we saw before, and that's going to come down here to the tank isolation. So the oxidizer isolation and the fuel isolation, these switches, and that's going to tell you what's going to go open. And now it's coming into the manifold down here. So we have the tank isolation for oxidizer and fuel, and that's going to come in, and it's going to be, these are actually, again, two lines as you see up here, one for fuel, one for oxidizer. It's going to come into this manifold, and that's going to fill, there's going to be an oxidizer manifold and a fuel manifold right here. And then when you turn this switch on, it is going to move the fuel into the jets, which are down here. So for one, as you can see down here, we have fuel one, forward one, and it's for left, up, down, and forward. And that's all for for the jet two. We have it here for forward, right, up, down, forward for 3, 4, and 5. And then we have open, close, and then the GPC, which is the computer controlling the switch. So that is, let's go back all the way up here, way up here to, those are the jets, to this right here. So we're talking about this forward portion, all of those jets, and that is all in the nose of the spacecraft, which is right here. So that's what we have for this week for the schematics. If you are a paying subscriber, and that again, cup of coffee, all you have to do is pay $5 a month, and you can go even deeper with us. So if you are a paying subscriber for our Patreon for a cup of coffee a month, and what you are going to see now is the extra part in the in those jets. So if we come down here, we see those are the jets. We have the regular, the primary jet, and then we have the vernier jet. Now the vernier jet is smaller. It has less power, which means it's more for the intricate portion, or intricate maneuvers that the space shuttle will need, because it's less propellant. We come down to, where is the manifold valves? Now, if you see down here, the forward manifold isolation 5 switch on the panel controls manifold 5 fuel and oxidizer valves, which control propellants from the forward vernier RCS jets only. So this is the vernier. If we look up at the manifold, the forward RCS manifold, that's the valves for manifolds 1, 2, 3, and 4 are the same, and they're AC motor operated valves, as the propellant tank isolation valves are controlled by the same motor switching logic. If we read down here, the switch is spring loaded to the GPC position, that's for the computer, general processing computer. When the switch is moved to open, electrical power is momentarily applied through logic in an electrical load controller assembly to energize a solenoid valve. Okay, that open and magnetically latch the valves, okay? To close the valves, the electric power is momentarily applied to energize the solenoid surrounding the magnetic latches of the valve, which allows the spring and the propellant pressure valve to be closed. So this right here is a solenoid. That's for number 5, which goes to the smaller isolation jets here for my isolation 5, which is for the forward vernier RCS jets only. So let's go back up to the top, and here we see the primary jet, and we have the electrical junction box with the fire command and fire pulse that they have. And then down here you see the biopropellant valves, and these are going to be solenoid. And so that is the difference between 1 through 4 and Jets 5. So if you come up here, you'll see the 5s are, there's 5 left there, there's 5 right. Again, it's very small movements. It's the vernier that they're going to use on the thrusters. And right, left. We have this one for right. Okay, so that is the right. We had the left. Where are there other ones up here? But those are very small movements, as you see. So those are where the vernier jets are, and that's what they're used for. So I want to thank you again for all of what you do. You're helping me out here to go over this. I hope you really enjoy how deeply I dig into these systems to help you understand how the space shuttle operates, this time in space. And this goes back now also to the Orion that's going to be going to the moon shortly, and also on the Starliner. So this system is basically what is used in the in spacecraft now. It's just theirs might be a little bit different, but this is how it works. And for all of your support, for helping me get more people to notice my this page and this Patreon page, I want to say I thank you.